Hi everyone, I'm Bryan Blunt, Director of Product Development for Times Fiber Communication, and today's tech tip is all about keeping moisture out of your cable. As almost everyone knows, corrosion caused by moisture migration is historically the most common problem in the cable TV industry. Usually, corrosion in cable is evidenced by common path distortion, or CPD. Before we get started talking about solutions to this problem, let's cover a couple of definitions real quick. First, we need to define moisture migration in regards to coaxial cable. Moisture migration occurs when there is a point of entry for air or water into the cable system. This can be caused by a cut in the cable jacket, a loose, poorly sealed connector, or an unsealed splitter or tap port, or things of that nature. Once the point of entry is established, the moisture begins to wick or travel down the braid and center conductor of the cable. Over time, the moisture can wick a great distance down the length of the cable drop and cause corrosion. Next, we need to explain a little bit about corrosion itself. Corrosion in coaxial cable takes place in the form of oxidation. The copper used on the outside of the center conductor, which conducts our cable signal from point A to point B, changes through this process to become cupric oxide, which is black in color. Likewise, the aluminum in the cable braid, which is also conductive, changes to aluminum oxide. Neither cupric oxide or aluminum oxide are ideal for conductivity. Lastly, we should explain common path distortion. Common path distortion, or CPD, is a return path impairment that can have severe effect on the return path signal quality. Although it can take on many forms and degrees of severity, it has a very distinctive signature. It is characterized by a significant rise in the noise floor across the return path spectrum, accompanied by beats spaced at 6 MHz intervals, also in the return path. This condition can cause a major reduction in return carrier to impairment ratios that can generate errors in digital transmissions. The reason it's important to understand all this is because moisture migration leads to corrosion, which leads to common path distortion. In essence, allowing any moisture into the cable system is bad. In previous tech tips, we have discussed how TFC's Quick Connect 2 F connectors prevent moisture from entering the system even if the connectors exist in a loosened state. Today we will discuss TFC's innovative solution to moisture entering the system through other weak links. We call it lifetime cable. Additionally, we'll be discussing some other key benefits to deploying lifetime cable in the cable system. Primarily, lifetime cable is designed to prevent moisture migration from happening at all. We can very easily demonstrate this with the following materials. Vacuum pump, purchased at any auto parts store. We have 2 samples of cable. One is our lifetime cable with the lifetime additive included, and the other is standard cable. You'll notice both sections of this cable are clear jacketed. We've manufactured this cable in our facility in Chatham, Virginia, and we've made the jacket specially clear so that we can actually see the moisture migrate when we do the demonstration. And then here we just simply have a jar of water to which I am going to add a few drops of red dye food coloring just for visual effect. And we're just going to give that a little swirl, get it all mixed in. And this should really give us a very good visual indication of the moisture actually migrating through the cable. In a normal cable sample, which is represented here, we can attach this to an air pump, and what we're going to do is simulate what happens when the temperature changes and the cable expands and contracts and then expands again and does try to draw air and moisture from wherever it can. Now we insert the cable end into the dye mixture, and I'm going to draw air through the cable, and we can see that immediately the tube starts to fill with the red dye mixture. That's because the cable is allowing air to travel through it, which allows a path for the moisture to migrate. Now I will disconnect the standard cable sample, and we're going to do the exact same demonstration with the lifetime cable sample. And just insert the end into the red dye mixture. And what we'll notice is that there is no dye traveling up through the braid or entering the tube. In fact, what we can see here with our gauge is that the red dye is not allowed into the cable because we are not even allowing air into the cable. The additive fills all the air gaps that would normally be used for the moisture to migrate through the system. Similar to flooded or underground cable, there is an additive inside the cable jacket that fills gaps needed by moisture to migrate. However, where flooded cable is filled with a gooey, flowing compound that's messy and difficult to work with, lifetime cable is not. The additive in lifetime cable is non-flowing and impervious to temperature fluctuations. It's safe for all drops, including indoor drops and aerial drops, and has been shown to actually act as a lubricant when connectorizing. In addition to improved connector installation, the actual preparation of the cable is easier, requiring far fewer braid touches on average than other cables. We can exemplify this by simply showing a standard piece of cable being prepped for connectorization. After we remove the jacket, we notice that we have to push down the braid several times. I have to touch the braid 1, 2, 3, 4, 5, 6, 7, and then inspect it, 8, and 9 in order to actually have the braid fully removed from the dielectric surface or the foil surface in order to apply the connector properly. The lifetime cable behaves completely differently and requires far less braid touches, therefore requiring less time. As we'll notice, I prep the cable the same way. However, I only need to touch it 1, 2, 3, 4 times, and I've achieved full braid separation, and I'm ready for my connector installation. So it's a much neater drop and a far easier and less time-consuming aspect of connector installation with lifetime cable. What allows us to not have to touch the braid as much or requires less braid touches is the fact that the additive keeps the braid together and has the braid perform actually as one unit in separate segments. It's also this additive that acts as a lubricant when the connector is installed, making connector installation easier. And even more importantly, the lubricant inside actually protects the grounding member, which is the braid, from the shielding member, which is the tape. As the cable flexes in the wind or during manipulation by our technicians or homeowners, what happens in a normal piece of cable is the braid is abrasive and tends to eat away at the protective shielding member, which is the foil. Because the lifetime additive acts as a lubricant, it actually extends the life of the cable when it's in motion. Instead of a cheese grater effect between the cable braid and the shielding tape, lifetime provides a protective barrier between the two, prolonging the lifetime of your cable. So for the elimination of moisture migration and improved longevity of your drop, and the reduction of common path distortion through your system, we encourage you to deploy lifetime cable by Times Fiber Communication in all of your cable systems. Thank you. This has been a Tech Tip by TFC, and have a great day.